Okay, we've been talking about the physical structure of roots. We've obviously gone through all the physiology, like the tree physiology in terms of how plants take up nutrients, water and what have you. And of course we've just heard a bit about soil biology, all the different sort of aspects of soil biology are. In terms of background, sorry, what would you... No. Okay, in terms of background, just in terms of where I am, I'm a forester, right? I started off in forestry, but I worked most of my time as a research scientist in CSIRO with forestry looking at plant diseases, soil, plant, microbial interaction, root rot diseases, dieback diseases. I then had another large contract in tropical crops and pastures looking at particularly, how do we use fungi, mycorrhizal fungi to sort of help plants colonize and establish sort of pasture agroforestry systems in northern Australia. And then another contract with the Division of Soils looking about regeneration of degraded soils. I retired about 10 years ago and we set up an organisation called Healthy Soils Australia, and this is really working with innovative farmers all over Australia looking at the whole point of, okay, how do we commercially utilise soil health in terms of the more on agriculture that we're really locked into. Over the last 5 years, I've been working with Major General Michael Jeffrey. He's our ex-Governor General of Australia. And when he retired, he too sort of said, look, we've got to really face reality here in Australia. It's our landscape and the resilience and the capacity of this landscape to keep on supplying essential water, food, biohabitat, bioenergy materials. At the end of the day, that's what it's all about. And so how do we ensure the stability and the resilience of this landscape in the face of climate change and all the other pressures? And of course, when that comes down to it, it's all about soils, okay? What is it that we have to do to regenerate the health of our soils? Because it's those soils that are the foundation of, in a sense, plant life. Plants have only been around on this planet, on this land surface, for the last 420 million years. Before that, we just had ocean and rock. And basically, it was the fungi that sort of colonized from the oceans onto the rock to solubilize nutrients that really started that colonization of land. They, as we heard this morning, they need carbohydrates, they need sugars. They're heterotrophs, they can't fix them themselves, so they piggyback their mates, the algae, with them. And of course they form lichens. And those lichens, and you see them all over now, whether it's concrete, roads, timbers, wherever, those lichens are still basically solubilizing rock and creating soils. So that's the start of pedogenesis, the start of the formation of soils. And it's that process which has actually created not just soils, the organic structure and water holding capacity of soils, but with that whole succession of liverworts, mosses, ferns, cycads, gymnosperms, angiosperms, and then eventually grasses. And it's really that whole colonization of plant life over 420 million years which has created our biosystem. And of course we fundamentally depend on that for all our food, all our habitat, our climate, our future. And the problem is, you see, we're really now facing a major crisis because we're stuffing that up in a big way. So the question is, what is it that we have to do? How do we get back to regenerating these fundamental soil processes to rebuild healthy biosystems? President Roosevelt made a very, very simple statement at the Dust Bowl in the 1930s in America: a nation that screws their soils screws themselves. Actually, he didn't say screw, he just said destroys, but basically the message was clear. If we don't look after the health of that soil, then basically we're finished. But of course the soil is only there as a means to support healthy plants, because it's the plants that give us our food, our oxygen, our water. So that soil-plant symbiosis and fundamental is critical. And in a sense, what we're talking about here is how do we do that? Today, up to now, we've really been talking about pot plants, haven't we? We've been talking about how do we actually grow plants And we've been talking about, how do we put them in an urban environment? And sure, can we build these, holes in the concrete that are big enough to support a tree, and can we maintain the systems? But we're a little bit more radical because we're tired and we can afford to be, because we're really making the point that, well, how do we actually sort of build an urban forest, an urban shelter wood, an urban ecology based on these natural fundamentals to sustain futures? So how do we turn that concrete jungle into actually a sustainable, autonomous, green ecosystem, and thereby a healthy future? See, that's so fundamental, because rather than trees in the landscape, trees and urban habitats being, yes, an ornamental aesthetic that a landscape architect can specify, I think we've really got to come back to the basics of, well, in a sense, urban forests, urban shelter woods have to be a foundation for healthy, sustainable communities in the future. So how do we do that? How do we use trees as tools in that landscape? And that's really where our focus is, and I hope that's relevant to your discussion, because a lot of people are going to depend on that for water, food, habitat, cooling, what have you. Why that's important is it's fairly simple. Basically, there's 7.2 billion of us now on this planet. They expect about 10 billion in 50 years' time. And see, all those people have a fundamental need. They need water, they need food, they need habitat, and really that has to come from that green biomass. 50% of the world's population now live in what we call these concentration camps, cities. 90% of Australians live in these cities. And so unless we get these cities green and vibrant and healthy and cycling, we're going to be in real serious troubles. And in a sense, urban forestry, urban shelter woods are not just a critical requirement in that case, but actually they are a powerful, constructive, positive tool. And you guys, in a sense, at the cutting edge of applying that tool to build a future. And so that's why this is so very important. If we look at what's actually going to impact in that thing, it's already happening now, and we see it all around us, and particularly here in Victoria. And you've had, of course, one of these worst experiences of it. Yeah, we've got climate change. Victoria, you're going to expect a 30% decline in rainfall, systemic aridification as climate pressure belts move. That aridification is going to impact severely in terms of the biosystems, not just your urban biosystems, but of course the biosystems around. And as you experienced in 2009, with that aridification comes fire, wildfire. So it's not just a slow thing, because you're going to get extreme events. And those extreme events, like wildfires, will actually sort of really threaten seriously. We have another fire in our regnans, our alpine ash forests, in the next 10, 15 years. It's cactus. Well, they might as well be cactus, because they're not going to regenerate, because they need about 20 years to put enough seed in there so the second generation can come. So we're really facing fundamental ecological changes, and of course the collapse of biosystems, and with that massive threats to, in a sense, the human societies that depend on those biosystems. So our whole focus is, okay, how do we build resilience into those biosystems? How do we buffer these extremes? How do we limit their impacts? How do we actively cool regional habitats? And of course, how do we rebuild those healthy soils that underpin that whole system? And in a sense, that's what we're looking at. What do we do? How do we use trees? How do we use urban forestry to actually achieve that? And of course, we know the evidence is there. We've heard a lot of it this morning. It's really quite compelling, because those trees are, really fundamental in providing shelter from extremes like wind. Now, we saw trees blown over in the wind, fair enough, but what about all those 99% of trees that basically don't fall over, especially if they're grown properly, and we know how to grow them properly, because the powerful effect of those trees in our urban landscape and providing that shelter from those wind extremes. The powerful effects of those trees and providing, in a sense, the control of desiccation, evaporation in that habitat. And again, we've always got to look at, where are the positives and put those on the balance sheets with, those few cases where we're not doing it as well as we might. Okay, so the other important thing is, in a sense, the powerful effect of those trees in creating not just amenity aesthetically, but the actual shade. I come from Canberra, that's where I'm living now, but basically, we've got studies there very clear. There's suburbs because of their trees, and when we had that period of 40 degrees days this summer, these suburbs were basically consistent 7 degrees centigrade cooler than other suburbs 10 kilometres away, which still were the big open, bare, exposed concrete jungles. 7 degrees cooler. So in a sense, what that means in terms of habitat, air conditioners, human health, heat stress, and the whole viability of urban futures is fundamental. Okay, so the power of urban forests to provide these benefits. Okay, the other important thing is, in a sense, these urban forests in terms of our hydrology, because actually when we come to it, really it's hydrology, water, that governs so much, not just of life, but of our climate, the whole lot. And we always look at this in terms of 100 raindrops, right? If we have 100 raindrops, then basically if we look at what we've got now in the way we manage agriculture, but also urban environments, 12 of those raindrops actually end up in our streams. 2 of those raindrops end up in our dams. And all our urban, industrial, agricultural, irrigation water relies on those 2 out of 100 raindrops in our dams. We, in Canberra, we've just spent $15 billion fighting about who's got what water entitlements to dry dams. It's your taxes, so don't laugh. But the point is that it's just stupid because 86 out of 100 raindrops fall on our soils. At the moment, 50 of those 86 drops are lost through flood runoff or evaporation. We're wasting 25 times more water that is in our dams because of our poor management. And so it's our regeneration of soil structures, it's our regeneration of these forests, both shelter woods throughout the grazing or broader agricultural landscape, but particularly in urban areas as well. It's that governs how much water is infiltrated, how much water is retained, how much water is available, the longevity of green growth of that biosystem, the resilience of that biosystem. Now, that capacity of soils to infiltrate, retain, make available water is totally governed by its physical soil structure, which is very much governed by its soil carbon, which comes back to where we are starting off about the actual biosphere, the trees, the vegetation growing in it. So that's really the tool, that's the only tool we have for regenerating these landscapes, these trees. Now, we just had Matt earlier sort of say, okay, here is the root exudate story, here's carbon, and again, it's compelling. I mean, we just see things above the ground because that's where we live, but 70% of plant photosynthate normally goes below ground. 30% in roots and up to 40, 50% varies, of course, species to species into these root exudates. And it just doesn't happen by accident because the plant is really saying, look, I have to invest in my symbionts, these mycorrhizal symbionts, because it's those mycorrhizal symbionts that are fundamental in giving me access to the limiting factor for my growth, the access to the nutrition and the water that I need. There's no shortage of sunshine. You know, we've got sunshine, CO2, nitrogen up there, free. Well, actually, they're going to put a negative price on carbon one day, they'll tell us. But the point is that, you know, there's plenty of sunshine, CO2 and nitrogen in the sky. But what's limiting plant growth is the availability of nutrients and water. And it's therefore the symbionts in the soil that are the real key, the combination to allowing plants to access those nutrients. And therefore it's the management of that biological interface between the dead inert mineral soil and actually the living cytoplasm of plants, which governs actually the whole productivity, resilience of plants. And it's prodigious. I mean, we can talk about so many bacteria number, but you really want to see it in a functional thing. A cubic metre of healthy soil, and we've measured it, contains up to 25,000 kilometres of fungal hyphae proliferating throughout that soil. And that hyphal network proliferates over mineral particles, organic matter particles, way out beyond the root zone, solubilizing nutrients, taking up water, and really driving that whole ecology. You know, we, again, in science, we've learnt the thing that, okay, plants take up water. Well, sorry, in nature, plants don't take up water and nutrients. Plants provide sugars to these microbial symbionts, and it's these microbial symbionts that totally dominate that soil nutrient-water interface with the soil. Okay, and so it's powerful because when we're saying, okay, what are we trying to do when we grow trees in concrete tubs or little concrete holes in the concrete, we're really sort of basically saying, are we actually utilizing these powerful ecological variables to our advantage? Are we getting, you know, the access to the nutrients and the water that we could be because of the lack of these microbial symbiotic relationships? And then the question is, how do we get them back? Okay, so really what we're making the point, there's powerful opportunities. There's actually the powerful natural ecology that can let us do that. But of course, we also have stunning case studies of where we have basically regenerated healthy, viable biosystems very practically, simply, profitably through the use of trees in landscapes, which is really the sort of challenge we've got. And of course, one of the best that we know of, and you know, I live in it, is in a sense Canberra. If you go back to 1913, Canberra, you know, Sydney and Melbourne had a big sort of stink about where's the national capital going to be, and they decided, well, look, we can put it in that clapped out old sheep paddock in the Monero Plains, right? Because it had been overgrazed for 70 years. It was hard, compacted, dry, dusty, hot, cold, depending on the seasons, you know, a really clapped out sheep paddock. That was how it was described. And it was only in 1915 when then Marion Mahoney, Walter Burley Griffin, and particularly Charles Weston sort of came in and sort of said, look, we've got to rebuild habitat. We've got to rehydrate. We've got to regenerate a healthy landscape. And they did it again through what you guys are into, urban forestry. How do we put trees into that landscape? And they, in a sense, over that sort of next 30 years, put millions of trees into that urban landscape. And now Canberra has completely different microclimate than it had in 1930 when it started. Okay, so if you look at the actual temperature relationships, the frost relationships, the hydrology, the whole wind exposure, you know, Canberra, because of its trees, is a completely different microenvironment compared to what it was before. And of course, as I said before, we've even got comparative control studies. Here are the vegetated, treed suburbs compared to the new concrete suburbs, 7 degrees temperature differences. Fundamentally changed. And these are the challenges that urban agriculture and you guys who are leading that really have to take on, because it's not a matter of just how do I get that tree to survive, but really getting that message, how do we turn this whole concrete jungle into an urban shelterwood habitat. Trees, of course, are also powerful tools in many, many other situations. Now, I mean, obviously we can talk about a lot of these, and obviously if we have question and answers later, I mean, happy to extend it. But for example, in terms of bioremediation of toxic sites, you know, we have very, very serious problems. For example, here in Melbourne, was only 10 years ago, and you were going to dig up a lot of toxic sites contaminated by oil and polyaromatic hydrocarbons that had seeped into soil from, sort of petrol stations and what have you, and you were going to build an incinerator at Dutson Downs near Sale to burn this all and turn it all into dioxins and furans and cause terrible problems. And of course, we stopped that because that was ridiculous, because there's far smarter ways. So there's people who are using fungi, trees, to, in a sense, bioremediate these soils, to actually break down these polyaromatic carbons in situ, in soils, and let the basidiomycetes, let these higher fungi actually break down these carbon compounds to recreate healthy soils. Okay, so there's a whole bioremediation opportunities where we can rehabilitate degraded, toxic urban habitats, make them healthy soils, make them healthy habitats. I was working with Soro in Brisbane at the time, and we were building a whole new airport at Brisbane. Okay, and it was taking up a lot of saline mud and silt from Moreton Bay and building a runway, but of course what we were bringing up is all this acid sulfate soils. Soils, sediments full of iron sulfate, hydrogen sulfides, and really it was going to be a toxic mess, because as that sulfide oxidizes, it forms sulfuric acid. As the soil's acidity goes massively more acid, all the heavy metals come out, and Moreton Bay was going to collapse because of this toxic mess. And again, it was a question, what can we do? What must we do to avoid that Moreton Bay sort of collapse? And again, trees were the answer, and it was very, very simple. We just simply, and if you fly into Brisbane Airport now, you'll still see them when you fly in. There's massive casuarina, glauca shelter belts on either side of the runway, and it was that casuarina glauca that created those environments, as we heard about this morning, where basically they create the organic matter on the surface, they create the deep roots, they create the anaerobic or lower oxygen concentrations in that soil, and actually buffer and stabilize that acidification of those acid sulfate soils. Okay, so we put a biological cap on those soils to prevent it going into that sort of toxic meltdown. Okay, so there's many, many applications in urban environments where you've got soil problems, you've got toxic problems, where in a sense you can use these fungi, these tools, these plants to actually sort of help rehabilitate that site. Now, we'll hear, of course, a lot about, trees have problems in the landscape. We heard about it this morning, problems with foundations, problems with drains. But really, we've got to just step back a little bit and say, as we talked about it this morning, this is just a simple civil engineering, design, communication opportunity. There's no problems. We can talk about, yes, how do we build foundations that aren't going to be impacted. We heard beautifully from that film that Andy showed, once a soil has a shear strength, that is too high for root penetration, and shear strength is governed by bulk density times water. But once we basically have a shear strength, then roots just don't grow into that soil. So there's no reason we can isolate soil around key buildings and structures where roots will not penetrate. Okay, the same as all these hard surfaces. There's no reason why we have to have hard surfaces covering, the whole concrete jungle. We can have porous surfaces. We can have surfaces that basically infiltrate air, infiltrate water, but still allow all the functional growth. Car parks, for example, they don't have to be asphalted. They can have open, porous, serviceable surfaces, and really sort of basically serve that dual ecological function, as well as, of course, all that car parking amenity. So, lots and lots of easy, simple, elegant civil engineering design options. So again, this whole point about trees and their problems in urban landscapes can be substantially overcome. Housing foundations, again, if you go to Queensland or go somewhere where you've got real problems with growth of vegetation and roots and what have you, yeah, they just put their houses on stumps, and they've never interfered with the foundations of a house on stumps. It's a question, why do we need to have our house, on the soil, in the soil, excavated from cuttings in the soil? Simply, what's smart about putting a house above the soil surface and avoiding the floods at the same time? Okay, so what we're trying to sort of really get to the point of that, these urban shelter woods, these urban forests are powerfully important tools, in a sense, for our future. They give us enormous benefits in terms of privacy, noise prevention, air filters, aesthetics, biodiversity, increases in property values, creating microclimates. And so we've got to really put that balance sheet in front of these councils, before the engineers, before the lawyers, to say, hang on a minute, this is really value, right? This is natural capital, this is social capital. These urban shelter woods really generate value for our community, for our future. And I think it's that becomes, in a sense, the message that we have to go out with, to say, look, we have to fundamentally redesign, this sort of urban habitat we're building in. We can redesign it. It is beneficial. It is profitable from all these areas. We have the tools to do it. Sure, there's always more problem solving and science that we can bring to bear on it, but we know more than enough to do it. We've had literally thousands of person years of research work behind that to do the job. And I think it's really a case of, how do we put these urban shelter woods, this urban regeneration, head and shoulders up there as a critical thing for the future. But look, I wanted to sort of more or less stop there, but really during the day, the most valuable thing is actually talking, interacting with you and answering questions and just really having that dialogue. So if we can save as much of that time for that, I'd certainly welcome those discussions. Thank you very much.